Hi, and welcome to determining the rule for the graph of a polynomial. Now, in mathematics, and I say this in a lot of my videos, we are always interested in doing things forwards as well as backwards. And many of the exam questions you will face are looking at you doing things backwards. That tends to test your understanding of the content. All right, not just regurgitation. That's the important stuff in methods, is the understanding. So today, that's very much what this topic deals with, determining the rule for the graph of a polynomial. Those of you who are following along alongside the Cambridge textbook, well, awesome. There are some questions there that I ask my students to do, but let's move on to our recap. So we have been looking at factorizing over and over again, factorizing, solving polynomials, and we have a range of tools available to us. The quadratic formula, the T method, the cross method, all right, and completing the square. They are for quadratics only, so anything x to the power of 2. Polynomial division, synthetic division, rational root theorem, greater than quadratics, okay, although we could probably use them on quadratic, but to me that would be overkill. So polynomial division. Why? What is it we're doing every single time? We are trying to find linear factors of our quadratics, such that we can, once we know our dilation, multiply it all out and get back to our general form. All right, so these are all the things when they've actually given me an equation in the form of, say, x squared plus x cubed plus 2x squared plus x minus 3 equals 0, and they've asked us to solve it. So that's what I would call doing things forwards. Doing things backwards are where they give you graphs or number of coordinates, and they ask you to then find the equation of the function. Right, so the equation can take different forms, which is why the question will normally give us what it is they're looking for, right? If you're lucky. Sometimes you can look at some graphs and you just go, oh, okay, I know exactly what it is they're looking for, and I know the format it's going to take. So here are some of the most common ones. So I suppose the first one here is y equals ax cubed plus bx squared plus cx plus 2. This is the general cubic function, right? So we don't know the values of a, b, c, and d. So what they have to do in the question, I'm making this just a bit smaller again so it all fits on, is they have to give you a number of important points, or in fact, just a number of points. There's one of my points, there's another one, there's another one, and there's another one. Now, the reason we do that is because there are 4 unknowns in this equation. And so we would need to have 4 pieces of information, which when we put it into our CAS calculator, and the good news is here, guys, you can use your CAS, it will spit out the values of A, B, C, and D. There is a proviso to this, but there is a general form of 1. The next one here is this cubic turning point form. So this is where they've taken the standard cubic, y equals x cubed, and they've translated it horizontally or vertically, and they've given it some form of dilation to get it to where it is now. Now that is lovely, because if they've given you one of these style of graphs, then obviously you need to know the turning point, because that's your value of b and c in my case. So there is my value of b and there is my value of c. And they would then need to give you one other point to find the value of a. Right? So in this situation, if we go to y is equal to a, x minus 2 cubed, because it's 2 translated that way, plus 4. So that one point, that turning point, has given me most of my equation. But to find the value of a, I need a value of an x and a value of a y. And obviously the easiest way to get a value of x and a y is to give you a coordinate. So 3, 6. Using that, I would now say, well, 6 is equal to a, 3 minus 2 cubed, plus 4. And I could go forward to solve that to find my value of a, and then state the rule for that graph of that cubic. Another common way is to express it in intercept form, all right? And that's very much what I opened this video talking about. The idea that if we know the intercepts, which happen to also probably be the factors, then I have 1, 2, and 3 pieces of information which help me put into this top equation here. So we could probably reformally state that as y is equal to a, x plus 3, which is this value here, that factor there, x minus 2, and x minus 3. Having got that information, all right, so I've used those 3 points, thank you, 1, 2, 3. I need to be given one additional point that I can substitute in to then find me the value of a. So again, I would then have 7, because that's my y value, is equal to a. X is 4 plus 3, 4 minus 2, and 4 minus 3. And putting all that together and solving will give me the value of a. I really, really like it when they give it to me in this format. It makes life pretty simple. So last one, all right. And again, when we looked at the idea in our previous video of quartics, we like the idea when they give us squares here or cubes for quartics because it means that it's either just touching or it's just going through. And so in this situation, this is my repeated root. That's the one that's just touching the x-axis. And as it turns out, there is my repeated root. I've got one other linear factor. That's the value here that crosses through the x-axis. And they always have to give me one other point. And in this situation, they've been quite kind and given me the value of 24. Thank you very much. So formally restating this, what would we have? We'd have y is equal to a. Remember, I don't know what the dilation is. I'm going to be able to find that out later. X minus b. Now, it's got to be the one that's not the repeated root. So in this case, it's going to be minus 3. And then x plus 2 all squared. We've got all the information we need there. I would then substitute my value of 0, 24 in. So 24 is equal to a, 0 minus 3, 0 plus 2 squared. And I would find my value of a and then restate my equation. So depending on the information they give you in the question, well, that depends on which particular form of the equation you're going to use. They might even be funky and give you ax cubed plus bx or any similar form. There's all sorts of ways of doing stuff, but ultimately what they would need to do is give you the right number of coordinates in the question to help you find this stuff out. Now, going back to this first one here, y equals ax cubed plus bx plus bx squared plus cx plus d. These are the type I've seen on exams over and over again, right? Where they give you 4 coordinates. Now, don't think that they're always going to give them to you in a graph. They're probably not. So if we look at this example here, and thanks very much, Cambridge, I have borrowed this question without meaning to infringe your copyright. But again, it's a really good example of what I'm trying to demonstrate. Now, here is the Casio ClassPad example. All right, I currently use the ClassPad, but I'm T-Inspire craziest too. I just don't have the instructions for those at this time. But good news, at some point soon I'll be recording lessons showing you how to use your ClassPad and T-Inspire to get all those fabulous answers you need for the multiple choice questions. I learned a lot recently about how your calculator can save you hours and hours of time if you use it properly, but that's coming up. So your ClassPad can solve this information for you. Let's break it down step by step. If we look at this first thing here, it says define f of x equals. Your calculator needs to be told what it's about to solve, and it's going to go f of x is equal to a. Now you can see a dot there, x cubed. That dot is a multiply. And a lot of people say to me, you know, oh, where is that dot on my calculator? No, there isn't a dot in your calculator. Just hit the times button. But you have to do it for each and every single one. C dot x plus d. Now the reason being is your calculator is clever, don't get me wrong, but it does not understand that ax cubed means a times x cubed. Mostly for lots of different things it does, but when you're defining expressions, put in those timeses. If I was to have $1 for every time someone made a mistake here, I would be at least about $50 richer. So that's $50 I'd prefer not to have. Thank you very much. I'd prefer everyone just to get awesome results. Having defined that, it's important to note what this means here. Remember, this is the same as y equals. We can interchange y and this f of x. And f of x basically means if I had f of 1, that means put 1 into my equation and out comes the value of y. So when I put 1 into my equation, out comes some value of y. And in a later video, which sounds a bit weird, how do I know what I'm going to record? Well, I've recorded all of this sort of backwards. I am aware that we can express a coordinate not just as xy, but as x, f of x. That is really important. It comes up in maths ever such a lot. But what does that have to do with the price of fish? Well, it all has everything to do with this here. I can actually express coordinates. So for example, the coordinate minus 1, 14 can actually be expressed as f of minus 1 equals 14. And if you think about it, what it means is when I put minus 1 into my function, out comes 14. So f of minus 1 equals 14 is the same thing. Well, why would this notation be important to me? Well, actually, you've already defined in your calculator the fact that the function can be expressed as ax cubed plus bx squared plus cx plus d. How many different pieces of information does the question need to give me? It needs to give me four coordinate values, which if I can explain to my calculator, it can solve this for me. So let's go back. We've defined what is this business here. Much as we have simultaneous equations, we can set up our calculator to solve any number of linear equations, just as long as we tell it how many pieces of information we've been given and how many things we're trying to ask it to solve for. So because we have four unknowns, we need to give it four coordinates. So now let's refer to this. On your calculator, you've already defined your function, and this is also the same for the TI inspire. Right? So you can define your f of x equals. Again, make sure you put those times in. Setting up the system of linear equations differs. On the TI inspire, you hit menu, algebra, solve system of linear equations, blah, blah, and you set it up that way. And you tell your calculator you want 4. On the Casio ClassPad, as it says here, you're lucky just to hit that icon 3 times. So I now need to tell the calculator 4 coordinates that it will need to solve. Well, it's given me 1 here. So the second step is, once I've done this, I would be doing f of minus 1 equals 14. F of 0 equals 5. Where did I get that from? This coordinate here. F of 1 is equal to 0. That's from my third coordinate. And F of 2 equals minus 19. That's from my fourth coordinate. All right? You've got your little box here, which you are going to fill in exactly the same way as A, B, C, and D. And as if by magic, out will pop your answers for A, B, C, and D. Now, I'm not going to do that here. You can do that as part of your own working. But the great thing is, all of the questions relating to this topic, and in fact the ones coming from the exam, all relates to the same idea of putting in coordinate values into the right form of an equation, be it this one here, or be it this one here, or in fact this intercept form, or this repeated root form, or anything even more funky, to be able to get you to come out with the general form of the equation, or the values of A, B, C, and D here. Practice makes perfect. Okay, thanks very much for watching. It's been fun. Have a good day, and I look forward to seeing you again soon. Hi, and thanks very much for watching this, another video by me, the Maths Guru. If you would like to see more videos, why not subscribe and get regular updates? Otherwise, hey, click on the left and watch our next video. Okay, thanks very much. Have a good day.